Today we're going to talk about arithmetic sequence, and a sequence is just a list of numbers. For example, we could do a list like 2, 4, 6, 8, and 10. And this list has 5 terms in it. 2 is the first term, so we would call this the initial value. And so we would call this n sub 1. That's the first term. And this term is the last term, and we would call that n sub 5. But sometimes these terms and labeling it this way is a little bit awkward, and so what we like to do is make a table. And so you'd say term and then value. So you'd say first term, second term, third term, fourth term, fifth term, and you'd put in 2, 4, 6, 8, and 10. So there actually is a pattern to these terms, and this is the other thing that a sequence talks about. A sequence has sort of 2 conditions. Condition number 1 is that you have your terms begin at 1. So you always start at number 1. So n sub 1 is always going to be your first term. And then the second condition is that these terms increase in increments of 1. So you have n sub 1, followed by n sub 2, followed by n sub 3, and so on. Now there is a pattern to this. There is a pattern. These just aren't random numbers that we selected. And in this case, the pattern is, in order to go from one term to the next, you're adding 2 each iteration. Plus 2, plus 2, plus 2. And this is a pretty simple sequence. Okay, let's go with something that's maybe a little bit more complicated. So if we started out with another sequence, again, we could say this is the term, and then this is its value. Maybe we just start with 1, 2, 3, 4, 5. So this sequence, again, will have 5 terms in it. And let's do this. Let's say 4, and then 9, and then 14, and then 19, and then 24. What is n sub 1? What is the first term? That's pretty easy, that's 4. How much does each number increase by? It increases by 5, and we're going to label this idea with specific vocabulary. We're going to call this the common difference. And so the common difference in this sequence is going to be 5, d equals 5. So with this information, you can figure out, you know where you're starting, and you know by how much each term you increase by. You could figure out values for a whole bunch of terms. So we figured out the first 5 terms. What would be the next term? And you'd say, oh, well, I would just use this common difference, and I would add 5 to it, right? 29. And then what's the next term? Oh, I would add 5, and I would get 34. And then I'd get 39, and you could do this for a while. So where things start getting a little bit more difficult is if I said, what is the 100th term of this sequence? So finding out the first, the second, the third term, those are pretty easy. But what's the 100th term? That's what we'd like to know. And one way that you could figure this out would be to write out all 100 terms, right? So you could start by saying, okay, 4, 9, 14, 18, 23, 28, 33, 38. And what you realize here is that if you were to do this tactic where you write out all the terms and you make a mistake, that mistake propagates throughout the rest of the terms. So I intentionally made a mistake right here. And so that's where my mistake is. And so now all the answers after that mistake are wrong. So this, not only would this take a long time to do, but it's prone to errors, right? Because you're doing like a mental calculation every step of the way. So what if there was a quicker way that we could figure this out? What if there's almost like a formula? By the way, this technique here, when you're writing this all out, this is called the recursive method. Recursive method is kind of like brute forcing it. You're going to write down every single step, and it's going to take you a long time. We don't want a recursive method. What we'd like is something else which is called an explicit method. And the explicit method gives you the answer right away. You don't have to calculate all of the numbers prior to the one you're looking for. You just calculate the 100th term right away. So let's stick with our sequence here. And let's break this down a little bit. So if I start with my term, and then I include the value, so first term, second term, third term, fourth term, fifth term. Let's start out and say the first term is 4, which it was. And now for the second term, what I do is I take the first term, so I take n sub 1, and I add d to it. So in this case, I'm going to take 4 and add 5. So how do I find the third term? Well, I would take n sub 2, I would take the prior term, and I would add d to it. So that's going to be 4 plus 5 plus 5, which is 14. How would I find the fourth term? Well, I would take n sub 3, which again is the previous term, and I would add d to it. So I would take 4 plus 5 plus 5 plus 5, and I would get 19. So in each of these, I'm starting out with the initial value, the 4. And then I'm adding the common difference to that 4. And we're adding the same thing. We're doing repetitive addition. And so instead of saying add 5, or add 5, and add 5, what is this equivalent to? If I add 5 to itself 3 times,
5 times 3.
It's 5 times 3. That's exactly right. This is multiplication. So I could say this number here actually is d, the common difference, multiplied by some value. What value? How many times am I adding 5 to itself?
3.
3 times. And what term is this? This is the fourth term.
N minus 1.
Yeah, it's n minus 1. That's exactly right. Let's see if this works. So let's go down a little bit farther, and let's say we're looking at maybe the 8th term. Okay? So if we've done this right, the 8th term should be 4 plus 5 times 8 minus 1. So that would be 4 plus 5 times 7. 5 times 7 is 35. 35 plus 4 should be 39. And we could do this out. It won't take very long to do it. The 8th term is 39. So our formula works. What's the 100th term? We would find n sub 100. So you would take your initial value, n sub 1, and you would add to that d times k minus 1. So in our case, this would be 4 plus 5 times 100 minus 1. So the 100th term of this sequence is going to be 499. How's this? You want to try one more? Let's do one more. The formula that we have to use is going to be n sub k is equal to n sub 1 plus d times k minus 1. This is how you find the kth term. What term in this sequence would you like to know?
The 50th.
The 50th term. Okay. So n sub 50 is going to be equal to, what's n sub 1? Yep, 105 is your first term. So that's going to be 105. Plus, what's your common difference?
Negative 3.
Negative. Why negative 3?
Because it's going down instead of up.
We just say the common difference is negative 3. And we're looking for the 50th term, so that means we're going to, k is 50, so that's going to be 50 minus 1. So that's going to give us, now you got to do some arithmetic. So if you continue this sequence out to 50 numbers, that 50th term is going to be negative 42. So find the first term in the common difference of the arithmetic sequence whose 11th term is 52, and the 14th term is 67. So let's take this information. Let's take this piece of information. The 11th term is 52. So what does that mean? That means n sub 11 equals 52. That's what that piece of information means. And this piece of information tells us that n sub 14 is 67. Remember, our formula is n sub k equals n sub 1 plus d times k minus 1. So if we were to take this first piece of information, n sub 11 equals 52, and apply it to this formula, we would get something that would look like this. When you take a look at this formula right here, can we solve this? Now remember, we're looking for two things. We're looking for the first term, which is n sub 1, and we're also looking for the common difference, which is d. And you notice those just happen to be the two things missing from our formula. So we can't solve it. Why can't we solve it? Because it has two variables, right? Two variables, two unknowns, and we only have one equation. So if we did the same thing with the second piece of information, we might get a formula that looks like this. So now we have two equations with two unknowns. You remember back in chapter 1, I think, when we were solving two equations with two unknowns and we did like substitution and elimination. So let's do that. Let's take the first equation, this one, and the second equation. How about if we take the second equation and we multiply it by -1? And something really nice happens with n sub 1. Cancels out. So we're going to end up with a formula that looks like -15 equals -3d. Once we have d equal to 5, we back substitute into one or both of the equations. Maybe we'll back substitute it into this one. So we'll get 67 equals n sub 1 plus 5 times 13 is 65. 2 is equal to n sub 1.
To find the common difference, can't you just subtract?
So what you're talking about is, you know that n sub 11 is 52, and you also know this guy here, right? So what you're thinking is, oh, well, I know that there's 1, 2, 3 steps in between those two numbers. And so that means there's got to be 1, 2, 3 steps between those two. So what if I subtracted 67 minus 52 and I get 15? And I know I have to cover 15 in 3 terms. So you would divide that by 3, right? And that is another way to get your common difference.
Do both ways work?
Yep, both ways work.
Always.
That doesn't give you the first term.
Right, it doesn't give you the first term.
But it helps you.
But it gives you the second, and then you can plug the second one back in.
Yep,
And that way you don't have to do like two.
that way you don't have to do the system of equations. So a sequence is just a list of numbers. Next, we're going to talk about a series. And a series is just the sum of a sequence. And this is represented by S sub 6. So how would you find the sum of these numbers?
Just add them up.
Just add them up. So again, this is kind of that brute force where you just like list them all out, right? If you add up the first 6 of these, you get a sum of 69. Could you add these up more efficiently? And what would that process be? So with this example, it's kind of a small number, and you might want to shortcut it. So let's start with an example that is really difficult to do. 1 plus 2 plus 3 plus ... plus 998 plus 999 plus 1,000. So add up the first 1,000 digits. 1 plus 1,000, that equals 1001. And then if I take 2 plus 999, that is going to be 1001. And then if I take 3 and add it to 998, that's going to be 1001. We'll call this number here n sub 1, and we're going to call this number n sub k. In this case, k is 1,000. And so you want to add those together. So you're going to take n sub 1 plus n sub k. That gives you this number. And then how many pairs are there?
500.
Yeah, 500. In our specific case, it's going to be 1,000 divided by 2. But if you're doing k terms, you would multiply by k divided by 2. So to find the sum of k terms, you would take the first term and add it to the last term, and then you would multiply that by how many pairs there are, which is going to be k divided by 2. So let's apply this theory up to our sequence here. So this is the sequence that we brute forced, right? We added each one. Let's apply this formula. So the formula was s sub k equals n sub 1 plus n sub k times k divided by 2. So that means the sum of the first 6 terms is going to be our first term, which was 4, plus our last term, which was 19, times 6 divided by 2. So 4 plus 19 is 23,
3 times 23.
and 6 divided by 2 is 3, and 23 times 3, 9, 6, same. So the formula works. Let's do this for Carl Gauss's situation. So if you were to add up all of these numbers, the sum of the first 1,000 numbers are going to be 1 plus 1,000 times 1,000 divided by 2. So if you're going to multiply this out, I would just take 1001, multiply it by 5, and then add 2 zeros. So if you wanted to add up the first 1,000 digits, the answer would be 500,500. So let's do this one, partial sum. The reason they use the word partial on this, so they're saying find the partial sum, that's because we could have an infinite sum. So they make a distinction between a partial sum and an infinite sum. When you're working with the numbers that we are always going to be working with partial sums when it comes to arithmetic sequences. It's always going to be a partial sum. We're not going to ask you to extend this out to infinity and add that. So that's why the word partial comes in there. But let's take a look at this. So you've got 1 plus 7 plus 13 plus a whole lot of other stuff, all the way up to 211. And we want to add these up. So our formula is s sub k equals n sub 1 plus n sub k times k divided by 2. That's our formula for the sum. So do we know the first term?
1,
Yep, it's 1. Do we know the last term? 211. Great.
212.
Do we know how many terms there are total in this sequence? So we need to figure out how many terms. And how do we figure out the number of terms? We have to use the formula that we started out with, that very first formula. Remember the first formula was n sub k equals n sub 1 plus d times k minus 1. And so we know some information here. We know that the kth term, the last term, is 211. We know the first term is 1. And what's the common difference? 6. So k equals 36. So in this series that we have, there are 36 terms. So we're going to take that 36 and we're going to plug it in 3816. This stuff here, the sequence formula that we just gave you, all that stuff, that comes from 7.1. This formula that we just talked about here, that comes from 7.2. So today we did 7.1 and 7.2.